projects and explain what problems you are trying to solve in the blockchain space.
So the DFINITY project is working on a thing called the internet computer. And essentially, we're trying to extend the internet. So the internet provides a public resource that any two computers can use to connect. And it was very successful because it's an open resource. Yeah, and if you think back to the 1990s, there were a lot of private networks. For example, AOL, CompuServe. In the United Kingdom, you had this thing called the Information Superhighway at British Telecom. But in the end, people preferred the internet, this open, public, decentralized network. So we want to extend the internet to give it more capabilities. So we want to extend the internet so that it can host software and data. So the objective of the DFINITY project is to create the internet computer that extends the internet and host the next generation of the world's software and data.
So in terms of random number generation and scalability, what things are related between randomness and scalability issue in your project?
Well, first of all, with respect to the random number generation, DFINITY uses a protocol called threshold relay that can produce a sequence of random numbers in a network of any scale. So, we believe the internet computer will be backed by a network eventually of, possibly 100 million computers. It'd be enormous. So the threshold relay protocol allows us to efficiently generate a random beacon in a network of any size in a way that is completely unmanipulable. No manipulation is possible, and also unstoppable. So, in fact, the protocol is able to produce a new random number with only about 22 kilobytes of network traffic. So it's a very, very efficient protocol. And yet, through the magic of cryptography, it cannot be manipulated. And it's almost unstoppable. So actually, threshold relay was invented at the beginning of 2015. And at that point, I realized I can create a new family of protocols that use the random numbers as a kind of engine. And this shouldn't be a surprise. All synchronous consensus protocols, and indeed Nakamoto consensus, proof of work that Bitcoin uses and Ethereum uses a variation of it, rely on random number generation. Just very, very basic, primitive random number generation. In Bitcoin, everybody races to solve a puzzle. And it's a brute force search for a hash, which is a number, beneath some threshold, right? Beneath some level. So, in Bitcoin, you create a block of transactions, and in that block there's a nonce. And you take the hash of the block of transactions. Is the hash beneath the target? No. Flip the nonce. Try again, is the hash beneath the target? And if you're the first person to find a hash beneath the target, you can broadcast a block. Of course, really this is just a kind of random number generator, right? So, the problem with proof of work is it's not very secure. It's quite easy to manipulate the random number generation of proof of work. And this creates a variety of problems. There are some other issues too that it's difficult to quantify the precise amount of compute capacity in a proof of work network and so on. So threshold relay is a great advance over this original Nakamoto consensus system, because now we can create random numbers in a way that's completely unmanipulable, cannot manipulate the sequence at all, in a way that's extremely efficient and allows us to produce random numbers very quickly. So actually, when I left Palo Alto, the DFINITY testnet was using a 0.65 second block time. 0.65 second block time. And the network is reaching agreement using a protocol that's in some ways inspired by Nakamoto consensus, but it's different. It's called probabilistic slot consensus. And it's a genuine blockchain protocol. It's not like a Byzantine fault-tolerant consensus protocol, which in my view aren't suitable for the decentralized network setting because they stop working if the network becomes unpredictable, if the asynchrony increases. It's a real blockchain protocol, but it's extremely quick and it can produce finality in a couple of blocks in normal operation, right? So an optimal operation is producing finality every 2 seconds in a public network. But it's not by using a fragile, we aren't achieving this by using a fragile consensus protocol. We're running threshold relay to produce random numbers in a way that's completely unmanipulable and unstoppable and extremely efficient. And we're using those random numbers to drive the probabilistic slot consensus protocol, which in normal operation can produce finality in a couple of blocks. So, we've in the first instance lent on advanced cryptography to generate these random numbers, and then we've used these numbers to drive other protocols. And of course, there are some other innovations in the probabilistic slot consensus protocol. We're using these threshold cryptography groups to notarize blocks. But yeah, we've succeeded in achieving a real advance. But that's just one piece of it. Back in 2015, I also produced a design for a thing called validation towers, validation trees, which you can drive using threshold relay and the random beacon. You can drive, and these things will scale out validation. So in the original architecture, you have a top-level chain which uses threshold relay and something like probabilistic slot consensus to create a master blockchain. In the bottom layer, you have shards, and in the middle layer, you have this thing called a validation tree, where the nodes of these thing called validation towers, and they're driven by the random beacon. Now, so that's actually, it's funny that there's been so much work on scaling because this was public science. The construct was described many times in 2015, but I think actually DFINITY may use a slightly different mechanism. It's choosing some different trade-offs. But it's certainly true that if you want to create a high-performance, secure, decentralized network, you need to start with random number generation, right? Unmanipulable, high-performance random number generation. Because that's how you're able to create games, for example, that can scale out validation. That's how you're able to select a leader in an unpredictable way so the leader can't be DOSed, right? For example. So, yeah, my prediction was back in 2015 that in the end, all of the major blockchain projects will end up running threshold relay to generate random numbers. Currently, they use an inferior approach, and the reason is we haven't released all the cryptography libraries necessary to create a threshold relay implementation. So you need this thing called a DKG, a distributed key generation protocol, and we have that internally, but we haven't released that. But I know currently a lot of blockchain projects are using our BLS libraries to generate random numbers.
Got it. And the next question is, many people are comparing your platform with AWS Cloud. So what things are more competitive and what things are possible in your platform?
Well, so the internet computer is a vision of a different kind of computation platform. So first of all, it's true that we're trying to extend the internet. We think that the internet should host software and data, not a big monopolistic company like Amazon Web Services or Google Cloud or Microsoft Azure. So that's just a fundamental thing. We believe that everybody should be able to build in an open environment, and that global society shouldn't need to rely on a small number of monopolistic providers of cloud services. And it's also, just as a more general point, pretty dangerous. So the internet was designed so that in the event of nuclear war, communications continue to be possible, right? That was why the internet was originally designed. And to make that possible, it had to be an open network without any central coordinator that anybody could connect to. As it happened, that had another strength. That meant that lots and lots of people could independently connect, and enormous growth was possible, right? Because anybody could now extend the internet, and anybody could provide services over the internet. And that's why it generated so much economic growth. And ultimately, we believe, that the internet should host software and data. And, it's better for humanity generally that we have an open platform. And also, at the moment, most of the cloud, most of the internet services running today reside in a small number of mega data centers. And, it's dangerous. A terrorist could fly an airplane into these mega data centers and we'd lose all our internet services. And people don't think about that, but there was a reason why the internet was designed in a decentralized way. It was so that it could be robust. So, we obviously, we'd like to see the hosting of software and data to be more in line with the original internet vision, and that's the aim of the internet computer. But in order to get people to adopt the internet computer and to build on the internet computer rather than Google Cloud and rather than Amazon Web Services and so on, you have to give them very compelling reasons, really substantial advantages. So we also are creating a completely different model for developing software. And as you know, we're using WebAssembly. So WebAssembly is this new standard for universal software. The designer of WebAssembly, the co-designer of WebAssembly, who leads the WebAssembly process, is a DFINITY staff engineer. We're also creating a framework that enables people to create end-to-end WebAssembly-based systems. So, in our vision, there'll be WebAssembly inside the web browser. As you know, the current version of the WebAssembly standard has already been implemented inside Chrome, Firefox, Safari, and Internet Explorer. And DFINITY wants to provide the back end. And we have a framework that will enable people to create systems on the internet computer using WebAssembly. Now, we believe there'll be a lot of adoption of WebAssembly, but it's still not enough. The framework that we provide greatly simplifies software development. So if you look at today's infrastructure, IT infrastructure, right, and the technology stack that people use today, it's very expensive with respect to human resources and human capital. If you take, the private IT infrastructure of a business or some government system and look at the total cost of ownership, the cost of the hardware is a very small part. The real costs are human costs, right? Because the technology stack is too complex. And we want to, so our objective is to make it much, much simpler to develop systems so that companies and governments can reduce the total cost of ownership dramatically. Now, actually, there's more hardware involved, right? Because the internet computer, performs a lot of cryptography, a lot of distributed computing. It uses a lot of replication, right? So that it can make sure your system is available, doesn't lose data. So the hardware costs increase, but the human capital costs come down a lot, and they're much bigger. So it's a kind of swap. The internet computer is a swap, is a grand bargain. We say, okay, hardware always gets cheaper. Like for example, you can buy a 1 terabyte SSD, solid state drive. 1 terabyte solid state drive for $100. 5 years ago it was $1,000 or something, right? The price of hardware always comes down. Actually, the price of good developers goes up. So the DFINITY proposition is, hey, you're going to spend a bit more installing software and running your computations and storing data. It's a little bit more expensive. But guess what? Your really big expense, the human capital, is going to come right down because we're providing a much simpler model for developing software. And so that's the first part of the proposition, reducing costs. The other advantage, of course, is that once you built a new software system or a new internet service, not only did it cost you less, but it's running on a hack-proof platform, a tamper-proof platform, because it's a blockchain, right? So it's much more secure. The platform takes care of availability, so your system will always be available. Your data won't get lost. The developer doesn't have to worry about that. The organization who owns the system doesn't have to worry about that anymore. We have technologies that can protect the privacy of data without the developer having to do anything special. And of course, systems on the internet computer are much more interoperable. It's much more easy to make them work together. So, there's a whole kind of raft of really serious benefits that we'll be offering to give reasons to people to build on the internet computer rather than on the legacy proprietary stack. So, on the one hand, we're saying, hey, look, this is the internet computer. We're extending the internet as a public resource, the internet itself can now host software and data. And you as a company or as a government department can build on the internet itself rather than on some private company who you must rely on forevermore. But we're going to bring your cost down, right? Because we've got a new software development model which has been made possible by advanced cryptography and new developments in virtual machines and language design and so on. We've got a completely new model for software development that massively simplifies the task of creating new systems and administering systems and maintaining systems. So your total cost of ownership will fall, and the systems you create will be more secure, more reliable, more interoperable, and preserve the privacy of your data. So when you put all of that together, you have a really compelling argument. And moreover, the internet computer supports new kinds of software. So there's a thing called autonomous software. And autonomous software can be used to create open source businesses, where you have a governance system in the software and it's tokenized, and the governance system can update the software, and you can reinvent internet services. Like, for example, you can create an internet dating app that makes guarantees about the privacy of user chat data. And this will have a governance system, right? Or you could create an open source Salesforce, right? You could re-implement Salesforce as an open source business to which all the developers in the world can contribute updates. And the governance system will obviously pay bounties and adopt updates, the best updates. But this will be like an open version of Salesforce, right? And it's incredible, I mean, right now you can see the challenges that companies face. I know startups in San Francisco, that spend hundreds of thousands of dollars a month on Salesforce licenses. Really expensive. Why do they pay so much money to Salesforce? Why? Because it's too complex to develop your own systems. Like, no business wants to get their own database administrator, right? Their own administrator of even Amazon Web Services. It's just all too complex and too expensive and too risky. Too difficult to make it secure, too difficult to protect all that private data, too difficult to maintain the system, even just too difficult to build it in the first place, right? Even if you can download the open source software, it's too difficult. So a lot of people instead choose just to pay huge fees to software as a service platforms like Salesforce. Well, why not, reinvent Salesforce as an open source business? And now, the internet itself can provide that service. in the form of an open system. So we think that's the future. We're trying to enable a move away from the traditional legacy technology stack, a move away from monopolistic private hosting providers, move away from traditional software components like databases and web servers towards a completely new framework that's based on open standards like WebAssembly and runs on the internet itself, on the internet computer. And we're trying to cut people's costs and enable people to create systems that are secure, reliable, preserve the privacy of data, and can interoperate. And to enable the creation as well of a whole new generation of internet services that are open and people are more comfortable building on top of, right? Because it's very dangerous building on top of a monopoly, of today's monopolies. So for example, remember what happened when Zynga built on top of Facebook, right? Zynga was this big games company startup in San Francisco, and they created Farmville. And their growth was astronomical. But then, they were building on top of Facebook, on top of the Facebook platform. And then Facebook changed the rules. And overnight, they couldn't grow anymore, right? They were kind of screwed. So that's an example of what can happen if you build on top of today's monopolies. But we believe the future of the internet's open, and that the future internet services will be much more open and foster innovation and provide a much better environment for entrepreneurs and startups. And this will create a kind of mutualized network effect, which really drives adoption once it takes off.
Very interesting. So when it comes to blockchain platform, we also believe it is very important for developers to adopt it to boost ecosystem. So do you have your own strategy to make more developers to use your platform when they implement applications?
So there are two parts to the adoption puzzle. The first part is, there's an enormous amount of capital invested in the blockchain industry, an enormous amount of enthusiasts and people that want to create decentralized applications. But today they have a problem. They can produce proof of concept, dApps, right? But these dApps never get traction because the underlying platforms aren't sufficiently mature. So, there are people out there wanting to create consumer internet services and dApps. There are people out there wanting to create corporate platforms. But all of them are kind of stuck in this limbo because the underlying platforms can't support their needs. And so we believe that when the DFINITY network launches, that many of the developers who are creating systems on other blockchains will simply move across, because finally we will provide them with a chance to go into production. So we think a lot of these existing blockchains will serve to bring new people into the market and allow them to develop their ideas, provide an interesting playground, if you like, but that eventually people will need DFINITY to actually go into production. So we anticipate a lot of migration onto the DFINITY platform when it launches. On the other hand, we're not really looking just at the blockchain industry. We're looking at the whole tech industry. We want to attract developers who don't know anything about blockchain. People that just want to create a private business system. So in that case, our strategy is really founded around WebAssembly. So the best analogy I can give is Node.js, right? So Node.js is a back-end platform for JavaScript developers. It's a horrible platform. I tried it once as an experiment to build a system, and I was horrified. But I think it's the most widely used back-end platform in the world, right? And the reason was that they recycled JavaScript developers. Like all these new, young developers came in to the industry, became software engineers, but they learned JavaScript and they built stuff inside the web browser. That's what they started. So they didn't want to learn all this old stuff. They wanted to create stuff using Node, right? So I think Node or JavaScript has 20 million developers, someone told me. I don't know if it's true, but it's enormous, right? It's the world's most used platform. So we believe that there will be mass adoption of WebAssembly in the browser. And people will start creating very sophisticated browser-based user experiences using WebAssembly. And DFINITY is actually developing languages and tools to help them do that. And we are going to create a very seamless experience so that you can create a system with a front-end user experience and a sort of back-end that persists data, right, on the internet computer, that's very seamless. It's end-to-end WebAssembly. So if you've learned WebAssembly and you're using some of these tools to create your user experience inside the browser, you won't really have to learn anything at all to extend that and put some of this WebAssembly code on the internet computer, right? It's going to be end-to-end and very seamless to the extent that you can write code in the same language, and you won't need to really know much additional information at all if you're a WebAssembly developer, using these tools to extend it to. So, in the same way that JavaScript developers, drove the adoption of Node, made it the most widely used platform in the world, we believe that WebAssembly developers will also drive the adoption of the internet computer. And so, it's on the one hand, I think there will be a lot of migration from other kind of blockchains from developers that really want to build production systems and actually hopefully get to the point where they can gain market traction and adoption. And on the other hand, we'll be targeting the mass market, of developers who don't have any blockchain skills and have, become introduced to WebAssembly and suddenly find that now they can create with great efficiency these complete systems, with a back end, with much less work, without needing to know about all these legacy tools, and that their systems are secure, right, and reliable and interoperable with each other, and can even preserve the privacy of data. So, we're of course looking at the blockchain industry, but we're also looking at the mass market and thinking about where software development's going and laying the groundwork for mass market developers to come onto DFINITY.
So, and there are many developers out there, but not jumping into blockchain yet. So, for inspiring traditional developers, would you tell us some use cases using your platform or any advantages about your platform?
Well, we're trying to create a platform that's future-proofed. So we haven't released it yet, but we have a framework for WebAssembly called Web Canisters. And we're going to push that live at some point. There's a lot of work still to go, but we're going to try and create a new open standard. And potentially people can even take this Web Canister framework and run it on other blockchains. So the first recommendation is that developers invest in skills that rely on open platforms, because there are hundreds of blockchains, right? How are you going to be able to guess which is going to become the dominant blockchain? And by the way, the history of technology shows that there will always be enormous consolidation. Once blockchains can actually provide the features people want, the speed, the reliability, the developer environment, and so on, there'll be rapid consolidation. So the danger is that you choose a blockchain that sounded good, but unfortunately when something like DFINITY launches and the market begins to consolidate, you chose the wrong blockchain. And now you invested all your time learning about some crazy proprietary, wacky thing, right? And so we're going to try and help people by pushing open standards, WebAssembly standards, that even other blockchains can adopt too, to try and reduce the risk that developers face getting caught on the wrong platform. Because at the moment, I think it's a pretty tough call for developers. The safest bet at the moment for a developer is to build on Ethereum. Ethereum has got a huge developer community, and the problem, of course, is that Ethereum only supports a very narrow band of use cases. it's really a smart contracts only platform. You can use it for things like ICOs and as a cypherpunk kind of applications, but you can't create a business system on Ethereum. You can't create a business service on Ethereum because the network's unreliable. And of course, for example, sometimes a big ICO runs on Ethereum and then the network runs out of capacity and doesn't work for a day or something. Business systems have to be constantly available and also provide good performance. So, currently Ethereum takes around 600 seconds to finalize a computation. It's very difficult to create a good user experience when you've got finality takes that long. So, there are a lot of things you can do with Ethereum, but it's a narrower band of use cases. But I don't think Ethereum's going away. I think Ethereum will remain as a kind of cypherpunk smart contract platform. And so I think probably Ethereum's the best area to invest your time at the moment. But the next generation, of course, will be of systems will be WebAssembly based. But it's not just WebAssembly. It's the framework that you use to develop your WebAssembly system. And DFINITY is working on standards that will enable you to create portable systems. That means you'll be able to run them, hopefully on lots of different chains. And so the risk that your investment in learning these technologies is wasted will be reduced.
This is the last question from my side. So, do you have anything you want to share or want to say to Korean public audiences?
Well, firstly, I hope anybody interested in the project participated in the airdrop. So I believe we've almost given, we've almost airdropped to 75,000 people now, which is, we're very pleased about. Watch the DFINITY project. Not many people. It's amazing because we didn't do a big ICO and we haven't had such high visibility. But people should watch the DFINITY project. We're always constantly trying to find a balance between protecting our work until it's time to release and telling people about what we're doing. But we do release updates and there'll be more news coming, and we're very interested to collaborate with people that want to build on top of a platform like the Internet Computer, and we are working on ways of giving people this WebAssembly framework before the network launches, so people can start building these kind of portable systems in advance of network launch. Please stay in touch with the project. And also, I'd say with all these things, watch the DFINITY team page. So, the DFINITY team page in a few weeks will be updated with even more people, and we're succeeding in hiring some of the world's top research scientists and engineers, and there's a reason for that. It's because the core science is very strong, and the reason DFINITY didn't run a big ICO is we were concerned about the opportunism of other projects, and we didn't want to be in the same category. So we're well intentioned, and you can see why people are attracted to the project, and watch the team page grow. Like the team page tells you about what's happening inside a project. And I think there's a lot of projects out there that don't even have team pages. And people should be very careful. I mean, I understand there's a lot of enthusiasm in Korea to invest in ICOs, but I think people should just be a little bit careful and ask a few more questions. Ask to see the team page, look at the resumes of the people involved, and remember that this market's going to consolidate very dramatically, and it may consolidate much earlier than people think, because there's a lot of work happening behind the scenes to develop the next generation of system.